Hello, everyone. Welcome to the AI Agents Hackathon live streams.
The AI Agents Hackathon is a free virtual hackathon running from April 8th to April 30th.
We're hosting over 20 live streams where you'll learn how to build agents using various Microsoft technologies. At the end of the 3 weeks, submit your project for a chance to win fantastic prizes.
And now over to our friends at Reactor.
Hi, everyone. Thanks for joining us for the AI Agent Hack. Before we start, I do have some quick housekeeping. Please take a moment to review our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our presenters to answer live. Our session is recorded. It will be available to view on demand within 24 to 48 hours. With that, I'd love to turn it over to our speakers for today. Thanks for joining.
Thank you so much for joining me today. I am Bethany Jepchumba. I'm a cloud advocate here at Microsoft. And for today's session, I'll be talking about how you can build your own AI agent with Prompty and then also an overview using Azure AI Foundry. Because I'm pretty sure most of you are not familiar with Prompty, I will start with the basics of first what an AI agent is, why it's even important to learn about AI agents, and then we'll go into how you can build AI agents in Azure AI Foundry, taking your playground into the code, and then from there, how you can optimize it with Prompty, like what other things can you be able to implement to ensure it's working well. I'll have about 3 demos to show you the different implementations of AI agents. One will be a basic AI agent in Azure AI Foundry and also implementing it in code. And then we'll go into what Prompty is, how you can build your own Prompty. And then after that, we'll go into, you've built your own Prompty, but now how do you add in the features that make it an agent? We'll talk about adding your data with RAG using Azure AI Search, and then actually using the Prompty file to be able to perform a task. I'll share the scenario and everything in the course of the session. But first things first, we are in this era called agentic AI, where everything is about Azure AI agents. And you might be wondering, what exactly are AI agents? Maybe this is your first session out of all the other sessions. So I'll do a bit of introduction. So AI agents are automations, but they're automations with a plus, whereby they do not just automate a process, but they can be able to reason over an entire request. So we have a framework called something like React. I'll talk about it later, where it's now thinking over, okay, what is the question the user has asked? How can I be able to use the tools that are available to be able to reply to this? And then for AI agents, what they normally use, the 2 things they use is the resources or the knowledge base available, that is being able to retrieve more context in your data. And then the second bit they do is they use tools. Most of the time it might be APIs where you're now trying to work with different APIs, be it Bing, be it a code interpreter API, to be able to now implement something and perform a task at the end of the day. So at the end of the day, the AI agents should be able to perform a task. And how exactly are they designed? First of all, these are AI agents. So the base of it is AI, where you have an AI assistant in there. And in our case, we're using large language models, or basically you can use any language model, whereby what the model does is probably generate an output from there. And then we have the retrieval system, where we have the data being ingested by the application. So we might probably ground in some data to be able to now help it respond to questions better. And then the last bit is action. At the end of the day, AI agents should be able to perform a task, perform an action, using available tools. I'll show you what tools are available in Azure and what other tools you can be able to implement. For today, we'll be using GitHub to try and make an action in GitHub using AI agents. So the difference between before and now is previously, when it was automation, you will just have probably Power Automate or an app like that. Nowadays, Power Automate has the AI agents bit. But before, it will just be, for example, you have an entire process, they have a trigger. So if someone joins in for the first time, the HR manager is probably notified, and then they share the new employee form. So basically, it's an automated process, but still there's a human in there to be able to go in and do the task themselves. And then next, we had chatbots, where now I'm guessing you've used ChatGPT or any other chatbot before. It had additional features such as being able to search the web. But chatbots basically was you're able to request for something and then it gives you an output. You're able to have the LLM generate something and it gives you an output. But then with agents, the HR manager, the purpose they serve is just probably supervision, because once probably a new employee signs in, they can be able to use an agent, go into the employee API and share the form instead of them coming in and sharing the form one by one. So you can imagine every time a new person joins this organization, it meant someone should be there to share basically to be able to share the form. But then once the agent comes in, the only thing the HR manager will be checking is evaluation of, is this okay? And then it's a very small task that has been automated, that is just sharing the new employee form. So it does not mean you can have multiple agents doing multiple things, but it does not mean you need to have something big to be able to automate. You just have that one API and be able to have it automated. So that's an example of how you can be able to use automated agents. So now the HR manager, the only thing they do is, this person, should this form go to this person, approve and go on, instead of them manually doing the process. There are different agentic AI capabilities, and some of them is, as I mentioned, we have this framework called React, where they reason over something and then they act. Basically, they do something from what the context they've been given is. So, for example, you have a question and they reason over, okay, this is the data that I have provided, these are the tools that I have, and this is what I should be doing. So if you ask a question that involves probably a code execution, it will go into the memory, look at, okay, what exactly is the data that needs to be provided. Probably you need to create a graph. So it will go into the memory, look at the data, generate the code, and then have that as the action, whereby you now have a graph from there. And this are the different techniques that it uses to be able to now come up with the action that's intended. Okay, that's it about the introduction. I'm pretty sure you've had this introduction somewhere else before, but then onto the good bit. Now we'll focus more on the actions of doing things and demos. So the first thing is Azure AI Foundry. If you're new to Azure or to Microsoft, this is our entire ecosystem of AI tools in one place. So for example, if you're looking for foundation models, if you're looking for the different Azure AI agent service, if you want to add in content safety, this is the place you can be able to do all that. And the good thing about it is you don't just get started with it. It also helps you to go into production with tools such as evaluations, governance, monitoring, and everything you need for your observability purposes. And in Azure AI Foundry, how it works is we have different bits of the entire application. So the first thing is the knowledge sources. In an agent, there's the knowledge sources, the memory. We have a way you can be able to connect with different memory services, with your own data. You upload your data and have it connected. And then the next thing is we have a lot of models you can be able to choose from. Last I checked, it was 1,840. So we'll check today and see how many are there and how many you can be able to use. And then we have tools that you can be able to implement to perform an action. One of the most recent tools I saw added was the TripAdvisor tool. So you can be able to even ask questions. If you're planning for your probably vacation, you can be able to ask and it will be able to do actions for you. So an example is a user might ask, help me book a trip to New York for a meeting, and they need to fly out next Monday and return on Friday. So you can be able to book a trip, one, probably booking the itinerary with TripAdvisor, two, probably booking it on your calendar, and three, probably you might even have an API to an airline that you can link in and be able to book your flight details and everything you need in there. So this is how an agent basically works. So you have the agent name. So you create your agent, you give it instructions. For example, you're a traveling and booking and expense management assistant. So what you do is you help us plan, book, and manage business travel. And the data you provide it is Azure AI search and probably local files it might need. And then you, as I mentioned, the core of it is AI. So you provide it with a different AI model or any AI model you want. And then the last bit is the tools. The tools are now the actions you want it to perform. Do you want it to do function calling? Do you want it to do code interpretation? Do you want to connect it to Microsoft Fabric for your data? Do you want to use logic apps? And then that's all when it comes to setting up your agent. And then once you set up your agent, the next step will be going in there and probably creating a thread. So when a user asks a question, I need to book a hotel for 2 stays, it will use the TripAdvisor API, probably search the nearest hotel, create a message, and come back with suggestions. And if a user is satisfied with the suggestions, you can even book the hotels from there. The other option is probably checking and seeing if we have a database available for the different do's and don'ts for a trip. So you might ask, okay, what is the daily meal allowance for a trip? And it will tell you it's 75. So what it will do, it will go to the SharePoint and then give you the output from there. Okay, so I'll do a simple code generation agent. So let's see how we can be able to implement it in Azure AI Foundry. As I mentioned, I can start with the overview. So the Azure AI Foundry provides you with different models. There are currently, let me give it a second. There are currently 1,900 models available, and you can be able to select from the models. For me, I selected GPT-4o. So ideally, you should select a model that can be able to work with agents, right? So GPT-4o meaning that cannot work with agents. So you should be able to select a model that's specific and you can be able to use it with agents. And then the first thing I did was, as I already deployed my files and models, the first thing I did was to create an agent. So I created my agent. So let me copy this, then I show you what I did from scratch. So I created a new agent. And in the new agent, probably I give it a name, movie trends. And then I give it some instruction of what it's supposed to do. So you're a helpful agent. What you do is provide information on movie trends, ensure your answers are concise, and include as much data, as much relevant data as possible. Then I added some grounding because I want it to be able to search the internet and give me the latest information, right? I want that to be the location where the data is coming from. So I grounded it with Bing search. And then the next bit, I added an action where I want it to be able to generate graphs for me. So I added code interpreter and saved. So you can see I've added the knowledge where it's getting the data from, and I've added an action, which is the code interpreter. So if I come to my playground, I can just come and say, let's test and see if it will do what I want it to do. So I'll come here and ask the question, hello, what were some of the top grossing movies in 2024, right? Because it is grounded with Bing, it should be able to give me the most updated information. And you can see it's looking for references using Bing. Okay, so it's given me a couple of responses. So it has like Avatar as the first one, and then Moana, and then Inside Out, it's Despicable Me 4. So what I'll ask next is, can it be able to generate a chart for me? So I'll ask, okay, generate a chart for the top 10 top grossing films, let me call them movies, in 2024. And the idea is it will use the code interpreter now to be able, interesting. I couldn't use, okay, let me start again. Clear, let me start again and ask the question again. What were the top grossing movies in 2024? Generate a chart of the top 10 in revenue. Yeah. Let's see if this works. Fingers crossed. So first it's using Bing search to look for references. Then it should call the code interpreter. So yeah, calls the code interpreter to now generate the chart. And voila, it's generated the chart for me. Let me zoom out a bit so that you can be able to see it. Yeah. So what it's done, it's used Bing to look for the data, and then it's called the code interpreter as a tool. And the action there is it's generated a chart for me. This is just a simple example, and how you can implement it in code. Let me go back to my code. And this is a basic. So I'll request for the producer to share the link to this repository. It has a link to both the code and the presentation. So this is an implementation of the same in code. So you will need to add in the tools that we're using. That is the code interpreter, the Bing grounding tool, and then we'll add the Azure AI project, as well as add in our default Azure credential to be able to now authenticate our identity. I'm using Azure CLI, so that meant all the requirements, what I installed was python.env because my credentials is in .env. I'm using Azure Identity and Azure CLI to log in, and then Azure AI project because I'm just using the project connection string to be able to, I'm using the project connection string to be able to authenticate and have access to the project. So the idea here is, one, we'll initialize the tools. So the first tool is the Bing connection tool, and then the code interpreter tool. Add it to our tool set, and then we'll load our model. So we'll just, from the connection string, we'll just add in our model deployment name, and then from there, we initialize our agent. So the first thing is we give it an instruction, what it's supposed to do, and then we create a thread. So once a user asks a question, you automatically create a thread. And then this is the question I've asked, what were the most popular movies and what is the gross revenue for this? And then we run. If it fails, it gives us an error. And then after that, we have it generate a file and save the file. And then at the end, we just delete the agent because we just wanted to do that one task. So if I come and run the agent down here, you can see, oh, I'm in the wrong, sorry. I'm in the wrong file. I'm in the wrong terminal. So if I come and run, you can be able to see it creating a thread. An agent creates a thread, created the message. I've already added the message up here. And then once the message is created, it will be able to now return the top 10 movies and then created a chart for this. And you can be able to see the chart has been added. I'm not sure. Let me know if you like a chart visualization for this. Oh, it's already deleted. Okay. But the idea is it's supposed to create a chart. So this is an example of a chart that has been created. So you can be able to see these are the movies, and this is the most popular revenue based on the movies that were selected. Okay, that's an example of now taking the agent the basic agent, code generator agent, being able to take it from our playground to code and now running it and having it work. And then for me, my biggest problem and what we are trying to solve today is in open source. One of the things I realized was it's very, when you have different parts, for example, we have the Prompty file. I'll talk more about Prompty. And we have different parts in the Prompty file. So that means when someone raises an issue, the issue might be 1 out of 20 different issues. And doing that manually, every day we have about currently 40 issues open, and every day there's like 1 or 2 new issues being added. So how do you know which issue belongs to which category? So what I decided was to create, to ease the work of this open source maintainer and to create a way such that after every, for me, it took like after every 1 minute so that I can be able to show you this in the demo. But probably you can do after every day, it just looks into your repository, checks if there are any new issues, and then automatically gives a label to your issue. So that's what we're going to tackle today. And I'm not sure if there's any questions, so let me check. And as I'm checking, I'll do a brief introduction to Prompty. And what Prompty is, it's an asset that helps you simplify. Oh yeah, there's no questions. How about amount of tokens? Is it expensive if I add 20 pages of PDF? I'll talk about it more when I go into RAG. I know she chose Bing. Will it be the same process if I choose ChatGPT? I'm using Bing as the browser. So let me show you. So here, the knowledge base here is Bing as a browser. It's the same as calling the Google API to be able to now search the internet and, okay, let me ask, generate top movies for 2024. So what it will do, it will go to Bing and look for the top movies in 2024, and then give me an output. And this is the output that it's given me. As you can see, it's not even called the Bing knowledge base anymore because I've already, as you can see, I already had it, like it already generated for me the 10. So it just looks at the cached image, cached data, and gives me that as the output. But the idea is instead you just have it as the data point for your information. Okay. Okay. I'll respond. So the next questions are about knowledge. I'll respond to that when I get to RAG. So back to Prompty. So what Prompty does is it's a file format that helps you see the way it's very easy to be able to come to the chatbot and add in, for example, your knowledge, your actions, your instructions, and everything. Prompty simplifies that process with a specification, which is an asset. And then it has a runtime where you now convert it. Like once you create your asset, it's very easy to convert it to any language that you want. That is Python. It currently supports Python and C# or the frameworks, LangChain or Semantic Kernel. And then the tooling is the extension where you can now, once you have the extension installed, you can be able to use it to ease your work, right? Okay, so this is how a Prompty file looks like. So the first thing is the same way we've created an agent, have it had a name, a small description, And then the next thing is adding in the model configuration. So which model are you using? And then the sample is the sample data that you want as the input. Then once the input is there, you create probably an idea of how you want it to be executed. So the instructions, you can name instruction system, whatever you want to name it. So you give it an instruction of what it does, and then have it, for example, if it's a customer tool, have it get the name of the customers. And then if someone asks a question and you want to use the name of the customers, it can be able to use it. And then you have the user question in there. As I mentioned, it has three main parts. That is the tooling, which is the VS Code extension, which helps to easily run it where you are and check if there's any errors and any evaluation, anything that needs to be done. And then the good thing about it is it has the highlights and syntax highlights, so you can be able to see where everything is at. And then this is now you taking your Prompty into code. And currently it's supported in Azure AI Foundry, it's supported in Python, as I mentioned, and LangChain, it's supported in C# and semantic kernel. And then the extension was built with TypeScript. And coming up, we are trying to have it also have a JavaScript runtime. And then if you want to implement it in your own language, you can implement it. Just go to the documentations and see how you can build it. The first thing is how exactly does Prompty work? So this is a basic Prompty file. Basic.prompty. This is a basic Prompty file. And how I created it, I installed the extension. So if you come to my extensions, you can see, okay, let me just search. It's supposed to come up as the Prompty extension. I'm not sure why it's not coming up. Yes, the Prompty extension. So this is what I installed. I installed the pre-release version, and then it came with this fun side tool where it has, in case you are using GitHub models, it has a way for you to implement GitHub models. And then you can be able to also build, you can be able to also look at the traces and all the runs and see where anything failed or anything went well. So what I'll do, I'll go to my files probably, and then I don't want to create it there. So I'll just come and create a new Prompty. And voila, it's created a new Prompty for me. I'll need to update my deployments and API version. If I don't want to do that, I can just erase. And then you can be able to see it has the first name, the context, the question. The context is the data provided. So the question is, you want to know about tens, and if you have some context provided, you have the first name, and you can be able to run it. So if you run this file, I've added my configurations here. So if you add this file, it will run on your terminal and give you the output. Okay, it's taking its own sweet time, but it's supposed to, yes, it's supposed to come up and give you an output. So it tells you more about the tent and anything you need to know. That's entirely how Prompty works. And then if you want to use, for example, if you want to convert this and run with something like GitHub models. So I'm using GPT-4o mini. So if I want to use something like, let me try Llama. If I run it with Llama, wait, what? Okay, let me just run the one that I had. This is an example of a serverless Prompty. So you see, instead of having the endpoint here is Azure OpenAI, and the endpoint is the Azure OpenAI service. Here I've changed it to be serverless, and it's running with GPT. It's running using the Models Inference API with GitHub Models. So if I run it, I expect to get the same output. Let me see if I can change this file. Let's see. Can it run? Okay, I've run it with yes. So it's still not failed. Yes. So now you can see, you can be able to test and see if it will run with Meta, you can see what the response is, what the output is, and determine, is this what I want? You can even see that you can compare the difference between what GPT-4 or Mini gave me and what Llama gave me and see, okay, probably let me go with Llama or let me go with GPT-4 or Mini. That's simply how you can create your first Prompty. And then I've seen a lot of questions on data. So I'll talk a bit about using retrieval augmented generation, that's RAG. So the first question is about the amount of tokens. Is it expensive if I add 20 PDFs? And then there's one also who's saying you're using a knowledge bot on top of hundreds of documents. So sometimes you get the response, sometimes not. Then same question, what is happening and how do you fix it around documentation, basically. And then the last one is when selecting models. Oh no, I'll talk about that later. So all this is using retrieval augmented generation. And how this works is the RAG you have in your own data. So when you ask a question to the agent, it will plan, query your data, observe, and then update the plan, query again, compile the answer, and give you the response. So as I mentioned, what I'm building is I'm trying to see if I can be able to, this is a code. I'm trying to see, let me show you first in Prompty. So I'm trying to see if I can be able to tag GitHub issues using a set of predefined tags. So these predefined tags, I want them to be in a database, in a vector database. So in case I want to update it, I can be able to update it, right? I can be able to say, this is the new list of tags. Okay, can you classify for me? So the idea is if I'm classifying an issue, I'll only need a title, a tag, and a description. And for the title, it's basically just the title of the issue, the description of the issue, and then the tags will be a JSON file. So currently it's just a small file. I don't know why. I keep forgetting which. Okay, let me see. Yes, this is where the tags are. So you can see it's just in JSON format, and it's just the tags, the name, and the description. So for example, if the name is the bug, this is what the description is. If it's enhancement, this is what. And then I've added specific tags in relation to Prompty. So for example, if there's any issue with the extension, I've added it as a tag. I've added if there's any issue with tracing. I'll talk more about tracing later. I've added if there's any issue with probably creating a new Prompty, probably creating a code with Prompty, and then anything else, model configuration, if there's any issue, if you're trying to configure your models, if there's any issue, you're using OpenAI, if you're using serverless, if you're using Azure OpenAI, and so on. So these are the tags I had. So what I did was back to Prompty. These are the tags I had. So what I did was I had it do some bit of function calling in a way. I added go into the data and create the tags in a more digestible format. And then I gave it some guidelines. So it should only select tags that match the provided list. If there's no tags that apply, it will return an empty array. The tags should be a valid JSON array. And it should just be that, no explanation. And I gave it an example. So for example, if this is the issue title, the issue body, this should be the tag list. So the output will be something similar to this. And then the next bit was defining. For example, a user will give, like the input will be the issue title and issue description, and the output should be the tag list. So when I came to Python code, what I did first was I'm using GitHub. So I created a GitHub token to be able to access the issues in my repository. So what it does, it just fetches the issues. If there's no new issues, it will just return no new issues. And then I created an Azure AI search service where now I got in my credentials, added it there, and then I was able to extract the content from the tags and the results. So with RAG, you can be able to specify probably how many items do you want to, how many, like when you ask a question, how many items do you want it to be returned from the index, right? And then from there, once that's done, I was able to run it with RAG. So the tags will be in the query, the description, and then this will be the argumented description. And what it should do is just give me the output. So this is what it does. So if I run it, it won't give me a response. Sorry, this is a file. So this is the previous one. I want to show you the previous one because I don't have any new issues. I'll create a new issue when I come to the agents. So what it does is it gave me the information. This is the issue. So the issue was you cannot use a sub-object in Prompty template. This was what the issue was, which was in semantic kernel at C#. This was the code, and then this is now what the issue was. None seem to work, so how do we do it? And then the category returned, it's in C# and it's under rendering the template in C#. So that's an example of adding RAG. So the question around when selecting models, you can request more tokens. No, the question around checked knowledge documents. So what you will need to do is you will need to define how many, like when the question is being asked, how many relevant documents will be retrieved. So that means if you have a PDF that is indexed with about, let's say, 100 files, instead of it retrieving 100 files, it will just retrieve the relevant 3 files. So that means it will reduce the cost. And as you've seen, when you do it with agents, once it creates a thread, it technically maintains the logic behind it. It's like it caches the data, so you don't necessarily need to. It won't necessarily need to go back to Bing because it already has the data. So when you ask the question, at first it will go to Bing, as you can see, it's just going to Bing twice, getting the data. This is probably 2 different web pages, and then it's giving you the output. And because you already have that data, it will give me the output. If I ask the question again and ask what were the top movies in 2023, you'll see it will go back to Bing and then look for some web pages, probably 2 or 3, and then generate a response based on that. Haven't shown me that section. Okay, let me clear chat and start again. What were the top movies in 2023? So it will go to Bing and it'll just probably look for 2-3 files. Okay, it's not giving me the source. I don't know why, but it should give me the ground where it's grounded at, and then give me the information. And you can see it's only used 11670 tokens. The other thing you can do is also limit the tokens. For example, in Prompty, you can add in a new where you have your model configuration, you can add in new model restrictions. So for example, if you wanted to restrict the number of tokens it should use, you can add that as a restriction. Okay, so this is, so there's a question around the trigger for GitHub tickets. So from the code, let me show you. I've added my GitHub up here. I've added my GitHub function to be able to retrieve the tokens and the issues, and then it gives me a response from that. Okay, so the last bit is bringing all this together. So you have your data and you have your tools, that is the GitHub agent. So how can I be able to, okay, let me just show you. How can I be able to now have the data, have it retrieve issues from GitHub and actually tag them. So I'll go to this, the Prompty agent. Same, the Prompty, what changes is now the file. So I've added more information. Instead of just adding the rag, I've added instructions. So it will only fetch and label the issues, and then it will define the label for the issues, process the issues, and then label it. And I've had it to get a trigger to run every 1 minute, right? Let me put it as 1 minute. And then what I can do, this was the previous one, right? It labeled an issue. So I can start the file, and then I can come to my repo and create a new issue. So what I'll do, I'll just go to Prompty and see if there's any current open issues. I hope I don't, 1 minute doesn't pass. Microsoft Prompty. And then once, interesting. So 1 minute. I want to add an issue. So I'll add an issue that's already existing in the Prompty file to actually have it more, to have it work better. So this is an issue. This is the title of the issue that's there. And then this is the issue itself. Let me just add it there and then create the issue. I don't know if I'm in the timeline of 1 minute. Yes, it's still checking for an issue. So let's wait and see. So the idea is, you've seen I've just created an issue. This is issue 4. No labels, no nothing. I've just opened a new issue. The issue is about the OpenAI API key environment, variables being ignored, and then it just has more information in the issue itself, right? Okay, still checking. So let me wait for it to finish checking. But then what it will be able to have implemented is it will actually go in and run something similar to this. So it will get the RAG information from the data. So it has information, it just finished before I even started explaining. But the idea is it gets the information in terms of integration. Wait, this is a more complex way. So if I come to my runs, because with Prompty you can see everything in a run. This is the latest run that has just occurred a few minutes ago. And you can see the labeled issue is bug, integration OpenAI, provider OpenAI, right? So this is the input. It goes in, it has the variables in the description. This is the title, what it does, what Prompty does, and then the description of the issue. And then this is the output. So you can look at what's happening in between. So the first thing is it loads the Prompty file, and then it this is basically what the Prompty file is about. The description is just tagging issues with a predefined list, and it adds all the information, the content of the Prompty file. And then we have it use Azure OpenAI to be able to classify it. And you can see this is the OpenAI deployment and details around it. And then this is the message that I've added. I don't know why it blurs everything, but the good thing is my keys are not being seen. But this is the content that's there, right? So the user has mentioned let me expand this. The user has mentioned, okay, this is the system message. So you're a GitHub assistant, this is what you do. And then the user, this is the content in terms of, this is the issue title. This is what is the issue that I've just submitted. And this is the information beneath it. And then what it's done, it's gotten the tags, all the tags available. It's stacked through the documentation, gotten the tags available, and that's part of my input. So now the output will be very blurred. But the idea is the output will now be in the terminal, you can be able to see it. So it's done a few content filters. It's been able to look at, based on the evaluation, it's been able to filter any probably hate, protected material, or anything in that form. And then it's gone in and done the classification of the different issues. And then once that's done, you can now come and see it's now added the issue, like it's now labeled the issue, sorry. It's now come in and labeled the issue. So you can be able to see if I add any other, it will now come in. And then the good thing is you can be able to see it has the primary issue, which is either a bug, enhancement, or documentation. And then it has additional issues, any other additional issues that are there. And it's just labeled only 3 labels with each issue. Okay, and then there's one that I ran and it had an issue. Let me see if it's this one. So with Prompty, no, this got the output, right? I was running the code and I kept getting the issue 422, meaning the format is not in the right way. Let me see, this one will open. I am not sure why they're not opening. But the idea is if there's any issue, instead of giving me the output, what it will have done, instead of giving me the output out here, you see everything has run, everything is okay. It will have told me what the error is. Or we can try and see. So for example, if there's no issue, now I don't think there's an issue anymore. So I can end this and then have it run again and see if there's an error, will it be able to tell me? Okay, that's how we do tracing and debugging with Prompty. So the idea is if there's any issue, you can be able to check and see from the runs that were there. You can even export this to Azure AI Foundry. In case there's any error in any of the runs, you can be able to check and see, okay, what was the execution, where did it fail, and why exactly did it fail. And as you can see, the output, I've added here the Prompty tracer. So it has 2 forms. So there's the console tracer, which is what is being run here in my console. And then there's the Prompty tracer, which is now its own file that gives you different outputs and different ideas of what exactly the problem was and how to fix it. And what I've done is anywhere I've added @trace is where now it's being traced. So you can add @trace to every level, but because I only want to know if the run is working well, that's where I've added the @trace. But you can be able to add it at any level. And then as you can see, it's also given like a detailed LLM call, including the message, the prompt, the parameters, the tokens, and even the latency. So let me open the run again. Yeah, so it's given me how long did it take, what was the tokens used per each. Let me go to this. It will give me, interesting. It's supposed to give me the number of tokens used. Yeah, this is something I'll go in and try and see what the issue is. But it's supposed to also give me what number of tokens were used for the input and what was the number of tokens for the output, to be able to now see, okay, where in the pipeline is there a delay? Why is it taking so long? But you can see my runtime was after every 1 minute. So it makes sense because I'm delaying everything by 1 minute. So that's basically how you can be able to implement RAG in Prompty. The idea behind it is how you can be able to have different parts, the knowledge, the tools, and Prompty in between to be able to supplement everything to work as it should. So if you're thinking of creating a multi-agent system, how you'll approach it when you're working with Prompty, basically I can break down my Prompty into different into different agents, whereby, for example, you have each agent do a specific task. So you can have the first agent probably a fetch agent, which pulls any new issues and probably uses function calling if you want to implement that. And then you can have a classify agent, which goes in, reads the issues, runs the RAG, and then classifies it. And then the other thing is you can create an evaluator agent. So you can literally create an agent to evaluate the issues that were generated and see, okay, were these issues right? Did I get everything right? And then lastly, have a label agent that now goes in and places the labels to GitHub. I'm guessing it's not giving an output because there's no new file added. So I'll try and figure out how to cause this to make us debug a bit. But basically, I can do something with the RAG agent. So probably, for example, this, I can come here and probably mess around with even just one bit and then try and run it. Let me stop this from running. Go to RAG and then probably try it again and see. It should give me an error, right? Not defined. And if I come to the runs under the Prompty RAG, there's one run that just happened immediately right now. Yeah. So it's telling me this is the inputs, and then it's giving me the output, which is now the error. And you can be able to see the error message clearly defined why there was an error, probably because I erased the search API key and it's not defined. So that's basically how you can be able to debug. So you can have all those multiple agents, and in each agent you have the trace file, the tracee being added. We're using OpenTelemetry for tracking and everything. So you can be able to do that. And then once you have all the agents running, you can be able to now check step by step, is this working well? And the good thing about having a multi-agent system is you can be able to have each system do a specific task instead of having it handle any complex or like running a long execution plan. And then the other thing is you can be able to implement probably evaluation. So instead of waiting for it to run and then trying and seeing if there's any errors, you can try and picture any use cases that might be there, any test cases that might be there, and add in the evaluation. And then you can also use it to test and monitor and have it working well. So this is an example of an agent system where we have the coordinator agent having the coding agent and the retrieval agent. So this is the system where you have one agent and then two agents reporting to that one agent. It's like when you have a manager and the manager is supervising different people. The other way you can be able to implement this is, as I've shown you, having different agents perform different tasks and then have an evaluation in between and finally finalizing on your task. That's it for my presentation. Let me see if there's any questions, but all the information, including my slides and everything you need, are in this repo. So you'll come to the repo, even the bugs that I've just created and I've been able to add the labels on. You can find the code here, and this is the presentation. Okay, I'm not sure why it's doing that, but this is the presentation where you'll find all the details of the presentation. And then these are the different files, the basic agent with Azure AI Foundry, how to create a basic Prompty file, how you can implement function calling with agents. I'll add the RAG bit, and then this is the final agent, having it be able to go in and look at the different errors and come up with a solution. And then the last implementation, which I've not done yet, but I'll probably do it later on, is having a multi-agent system where each agent is doing a specific thing. You can see the only thing here actually is the ideas of what the agents might be. So like basically having a fetch agent, a classify agent, an evaluator agent, and a label agent. But that's it for my presentation. As I mentioned, here's the link. Let me see if there's any questions on the chat. Okay. Thank you for the good explanation. Thank you, very interesting. Okay. I think I've answered all the, oh yeah, there's one question. When selecting models, you can request more tokens per minute, but can you request more token completion, as some models have a limited number of completion tokens? So if you're using Azure, you can be able to, let me show you, in models and endpoints, you can be able to come where, I don't know why when you're trying to explain something, it takes so long to load. And then when you're doing it on your own, everything is just working. So what I've done, I've gone to models and endpoints. Let me expand this. I've gone to models and endpoints, and then under models and endpoints, I've selected my model, which is GPT-4o mini. And then you can see I have a rate, my rate limit is so high. I have a rate limit of 1 million tokens per minute. Yeah. And then 10,000 requests per minute. So if you want to increase, depending on your organization and everything, the rules that are there, you can just come to the edit button, and then this is where you edit your tokens create per limit. I'm trying to have, okay. No, let me just have it full screen. Let me reduce the size so I can be able to see. So I've come to the edit button, and then under the edit button, you can be able to see what your tokens per minute rate limit is, and you can either increase or decrease. I technically don't need 1 million because, yeah, but it's good for my presentation that I haven't hit any limits. But the idea is you can be able to toggle this to increase to the maximum level that you want. And then once you're good with it, submit the changes and it will be updated. Your deployment will be updated. That's how you basically improve your rate limits. For GitHub models, it has a daily rate limit because it's free. So if you're using GitHub models, you might not necessarily, I hope this is the right one. If it's not, no, it's not. GitHub models. Marketplace, no. Yeah, this one. So if you're using GitHub models, there is normally a rate limit per day. Let's say, or 4 mini. When you go to it gives you the tier. So for example, this is the context, the input and the output, and then the rate limit tier, mine is custom. I don't know what it means, but most of the time you'll be, yeah, this is what the rate limits are. So for example, if you're using Copilot Free, Copilot Pro, I'm using, I think, Enterprise, I don't know. But you'll be able to see how many limits do you have. These are the limits per minute, per day, and then how many tokens requests can you have in and out. Yeah. So for that, you might not be able to change the limits per se, but yeah, that's the maximum. Okay, Rohit. Oh, I already answered the question. So for your question, I replied, the first one, you're building a bot that works on hundreds of documents. I don't know why it does not respond back, that it could not find the answer, but mainly it might be because of the data that's in there. So or even the strictness of it. So you can reduce the strictness of your RAG, or you can also be able to have it have a wider scope of data. And then also you can use vectorization. And then when a user checks the knowledge documents, answer the query available, why is it happening and how do we fix it? That I do not know. To ensure the knowledge bot is accurate, the best option is one, to choose the right indexing. There's a session on RAG. I don't know if there was a session on RAG a few weeks ago where they were showcasing the different elements in terms of RAG. So like which type should you choose? Should you choose semantic or vector? Should you use what Azure AI search uses and everything? So you can look into that and see, okay, these are the different components. This is how you should do it. Yeah, that's my response to that. Otherwise, thank you so much. Continue with the Agents Hack. Any information you need, you can find it at aka.ms/agentshack. And yeah, see you next time. Bye.
Hi, everyone. Hope you enjoyed today's session. If you aren't registered for the AI Agents Hackathon yet, register now at aka.ms/agentshack and start hacking on the agent of your dreams.
And if you have any questions along the way, just post in our GitHub discussion forum or attend our live office hours in Discord. And of course, make sure that you keep attending the live streams to keep learning about agents.
Once your project is ready, submit it before April 30th at 11:59 p.m. PT to be eligible for our prizes. Thanks for joining.